Well, hi, good morning. Thank you so much for joining me again in my shop here on September 4th. Now, if you look at my bench, you'll see a capacitor sitting right here. This is the capacitor that cooked in the radio yesterday, maybe the day before yesterday, depending upon when you're watching the video. And then I took this capacitor, it clearly overheated. I saw it overheating, no question, but in the radio it wouldn't do it again. And when I put it on a DC leakage test, it actually tested kind of okay. Not good, that's for sure, but certainly didn't look really, and he didn't test any different from any other capacitor. Why did this one fry up? Well, one part of the picture was this was right across the 120 volt AC line coming in. So I'm going to do that again. I tested it on DC. Maybe that's just not going to highlight the problem in this capacitor. So I'm going to plug it right in. And this is off right now. So I'm going to hook up the capacitor. I don't expect anything to happen instantaneously. I expect this to take time. I think part of the picture is a thermal runaway situation. I think that's part of the picture, so this has to heat up a fair bit before it really heats up. That's what I think is going to happen. So I'm going to apply power here. The power is going to get there through these light bulbs, actually just one of them. If this shorts out or something really serious happens to it, the current flow into it will be restricted by the light bulb. I just add more protective devices here. I've got a fuse in the line here. This thing has a circuit breaker in it. Lots of protection here. Crazy amount. So I'm going to turn the power on. And we have the ability to monitor the temperature here using this thermal viewer. Just see what happens. Again, I don't expect anything to happen suddenly. I expect it to be kind of a slow process until towards the end. Okay, here we go. Now, is the light even going to come on over there? No. I'm just going to turn this down a wee bit. There we go. So I have 120 volts on this guy right now. And what I noticed about it when it started overheating was the sound it made, like frying bacon. Turn on the viewer here to get a base temperature for it. So it's actually visible in the viewer already, right in the middle, and the temperature is 21 degrees. Temperature of my bench, it's about the same. So, okay, you can see it there. I can see it there. You can't in this viewer. What's that? What's that huge red thing? This is just a little warm. I think I have this set too sensitive. Let's make it a little less sensitive. Okay, so red is going to start somewhere around 30 degrees. We'll see a red on here. Well, I will. You may not. There's nothing happening at all right now. I can certainly see the capacitor on the screen. Okay, we're going to give it a little bit of time now. Wires and things like that, resistors, their resistance goes up as they heat up. The hotter they are, the greater the resistance. Semiconductors go the other way. The more you heat them up, the more they conduct. I'm not saying this is a semiconductor, but it's going to have that attribute of the warmer it gets, the worse it's going to get. A bit of a So it was in the radio for about 20 minutes before I noticed anything. So we're going to leave it like that. It's 9:09 right now. So let's let it do its thing. And I'm going to go and get a cup of coffee. I'm actually going to leave the shop. I don't want to stand around for 20 minutes. And you don't either, so I'm going to stop the video here. Okay, it's only been a couple of minutes, 9:11 now. The reason for that is because I want to keep a close eye on this at first, in case it still 22 degrees, hasn't warmed up at all. Now this meter back here is an interesting feature where usually I have this set to the output voltage, but it has another setting. I can actually read current flow. So we're going to flip it to that. Okay, on the current flow setting, this is 1.5 amps all the way over. Now I'm going to cut the power briefly and watch this pointer just very carefully. Can you see it drop? Very hard to see. Very hard to see on the camera. But this actually dropped a bit, so I'm able to monitor the amount of current flowing through here. But frankly, I'd rather monitor it by watching a light bulb. But I don't know what to expect. I'm trying to be ready for everything. Really don't want to fill my shop with smoke this morning, so. But now I have a cup of coffee waiting for me. So this really not heating up here. 22, 23. The thing about thermal runaway like this is it goes from okay to bad. It takes a long time. It goes from bad to worse really fast. So, and what's the worst thing that could happen? Catch fire. It's remotely possible. This is a piece of porcelain that's sitting on top of. Okay, I'm gonna gamble. I'm gonna go drink some coffee and come back in a few minutes. Okay, let's see. It's now 9:24. A fair bit of time has gone by, and looks nothing showing up at all. No heat whatsoever. A little bit surprising. Well, I got lots of coffee to drink, so I'm going to let that continue. Exactly, all told, the radio's operation time could have been as much as 45 minutes yesterday before this thing started cooking. It just would have been, the radio would have been turned on and off during that period a couple of times. Let's leave it a bit longer, see what happens. Okay, 9:33, so we're about a little over 20 minutes. And it looks like nothing's happening. And I see nothing with this viewer whatsoever. In fact, when I first did this, the capacitor showed up just a little bit warm, and that was probably from me handling the capacitor and heating it with my hand a little bit. So it's actually cooled down to room temperature. I can't see it on the viewer at all. It's the same temperature as everything here. Is it really hooked up? Do these click leads, are they really sending in power there? I mean, the meter here showed some current, but can we really believe it? So I'm going to try and check that. AC 300. Okay, I'm going to touch the capacitor leads. Yeah, this certainly is. Voltage on the capacitor leads themselves, for sure. This is doing what I wanted it to do, except it's not doing what I thought it might do. Makes for a very boring start. Okay, well, we're going to leave that going as long as I can, but at this point it's just showing nothing. So how do you explain this? If it was frying in the radio and not anymore. I mean, is it possible that it dried itself out? It got hot enough, it drove out the moisture that was in it? This white surface here you can see on the capacitor is foamed up wax. So that's the moisture in the wax coming out. When I worked in the power company, the cable splicers who I came across quite often, these are the guys who would be in the manholes hooking up these wrist-sized conductors to each other using large amounts of solder, ladling molten solder, and all kinds of stuff. One of the things they would do when they're making a splice into an existing older cable, they would check it for moisture. These cables were insulated with paper, literally strips of paper. Yeah, high voltage power cables, 8,000 volts, paper insulated. They would peel off a little bit of paper because they had to peel it off to make the splice anyway. Then they'd hold the paper, so the paper, I can demonstrate this. They would hold the strip of paper, it wouldn't look like this, it'd be a strip. They'd hold the strip, get a lighter, light the end of it, and it would start burning. Now, if there was no moisture in it, you could watch it burn. It would burn slowly upwards. You could see a buildup of oil just ahead of the flame, and the flame would burn quietly and would just go up. If there was moisture, and this is a tiny amount of moisture, then at the point where the flame is touching the paper and that oil is building up, you'd see a lot of spitting. You'd hear it, and you'd see spitting. And if the paper was really quite moist, then the oil would foam, foam up. It looks something like that. And that's how they could judge how much moisture was inside the paper. I say, well, how'd the moisture get in there? I won't go into that, but a failure in the sheath of the cable would allow moisture in. So that's what I'm expecting to see here. Some wax would act like the oil in the cable, and if there's moisture in it, it would foam up, and that's certainly what was going on inside the radio. But here on my bench, once again, there's nothing going on at all. It's so surprising to me. Okay, we'll just leave that there, and I'll try not to accidentally touch it. Maybe I can just move it off to the side here. Ooh, let's take this, move it off there. Okay, let's go on. What about this radio now? What to do next? So it's been an interesting time working on it because unexpected things have happened, and that makes it kind of fun and interesting. So where are we now? Now we've got this guy, which is carrying the audio from the volume control to the detector tube, where there's a triode to amplify it, and we've got this guy. What is this guy? This guy, well, he's got one terminal on this positive lead of this filter capacitor, and the other one it's hooked up where this black wire is heading out. I would guess it's going up to the speaker. So the speaker, this is a tricky speaker. Let's take a look at it. It's got the whole ball kit and caboodle going here. So it has its own transformer, and it also has a field coil. There's a field coil. Did I realize that? I think I did, and then I forgot about it. Usually when a speaker has a field coil, the field coil is being used as part of the power supply. It becomes a filter in the power supply, an inductor, or a choke. A choke would be the right word for it. And you don't need very much capacitance if you have one of these inductors in there. But I've gone and put in fairly large capacitors. According to the schematic, the original capacitor is bigger yet. I think it was an 80 microfarad. I put in a 50. So, what wires what? The object here is to get on the schematic and identify this capacitor. It's probably a lot easier than I'm making it out to be. Let's take a look at here's my pointer stick. Use this. So it's on this pin of the tube here, and that'd be pin 1, 2, 3, pin 3, pin 3, and I think that's the output tube. Pin 3 of the output tube. Let's take a look at the schematic and see what we can see. Okay, pin 3 of the output tube. 1, 2, 3. There it is there. Let me just move this over a little bit to the speaker, but it's actually to the speaker transformer. So this is across the windings of the speaker primary and the output transformer that's mounted on the speaker. This is a very common capacitor. This is found in all these radios. And what it does exactly, I could say some things, but I'm going to get the book out and have a look, because I think I probably don't have the story quite straight. I think it's for dumping any RF and keep it away from the speaker transformer, I think, and perhaps has something to do with oscillations, stopping oscillations, but I'm going to look in the book and find out. Meanwhile, what am I hearing? Am I hearing I'm hearing things. I thought I heard the capacitor starting to crackle. Yeah, I'm going to start hearing things here. Let's take a look at that capacitor. No sign of heat. Yeah. No sign at all. Nothing whatsoever. Huh. I didn't grab the wrong... Did I grab... No, I couldn't have grabbed the wrong capacitor. That has to be the one. Look at the foamed up oil on it. It can't be the wrong capacitor. Well, leave it longer. That's what I say. Leave it longer. Well, it's been 45 minutes for that capacitor. Nothing is happening. It's still at room temperature. It's not elevating at all. In the meantime, let me get my book here. And reminded myself about the capacitor we were considering, but there's another one here that's of interest too, and that's this guy, which is very common, off the plate of the output tube, a capacitor going to ground. And over here in this diagram, look at this. So this is hard to see here. Something's written in tone control. There's the capacitor, there's a switch, and it's right across the output primary, output transformer primary. Tone control. Couldn't find any good description. Well, I could actually. This is C23, and they talk about it up here. And it says, when the switch is open, there is no shunting action. This is the treble position. So open that switch, and the treble will be increased, or will not be decreased. That's really what we should be saying. In the base position, when the switch is closed, C23, which is a 0.04, shunts some of the high audio frequencies out of the speaker. Earlier in the book, when it talks about this capacitor, it says these tubes can produce a lot of harmonics, and these high frequencies are unwelcome, and you don't want them. You don't want them making it to the speaker. So you can position a capacitor here which will remove some of the higher frequencies. We're not talking RF here, we're just talking about high audio frequencies. I thought it was to snuff out any RF. And certainly it would do that if any was making it that far. And what's it, the last video or video before, I tried to hunt down RF flowing in the audio circuits, and I didn't really get very far before stuff started happening. So the purpose of this capacitor then is to simply, over here, this capacitor is to direct higher frequencies around the output transformer so they don't go through it and don't come out the speaker. So if this guy's capacity has gone down, then you would expect more highs. You expect the radio to become more shrill than intended. There's no other tone control on here. So what to do? Well, it is, I was going to say it's got quite a voltage across it, but it actually doesn't. I don't think it would have much of a voltage across it. It has the entire audio primary signal across it. Well, might as well change it. I'm not sure it's going to cause any benefit. Is there anything we can do? I don't think there's anything we can. I think this is just change it and stop fluttering. Okay, so we're going to change that one out. And should I at the same time change this guy? This is the audio capacitor. Maybe we'll save that right for the very end and see what it does. So I'll change out this guy, 0.03. Okay, I will do that. Okay, let's give this capacitor a test. It looks to be in good shape. But you can't judge a book by its deceiving look. Okay. 50 volts. Opens up. Not quite all the way. 150 can't do it. They're all these capacitors have a very similar level of degradation. This guy was probably working in the position it was in. I don't think it's too critical. It'd be leaking a few coulombs, not coulombs, it'd be microcoulombs here and there. So I'm going to put in this nice capacitor. Then we'll operate the radio. Okay, well, I'm ready to plug in the radio and try it out, but I still have the capacitor sitting here. And, it's developed absolutely no heat whatsoever in it. Okay, let's cut the power to it. So, that's surprising. I thought this thing would cook up. No, it's completely room temperature. Nothing at all happened. Just totally surprised by that. Let's use this guy and see if we can measure the capacitance of this capacitor. It's supposed to be, I can't remember now, 0.05 I think. It did show a bit of a leak when I did the other test on it, so this may be bogus. Let's see what it says. It says 0.04 and 1.1%. I mean, that's not bad. That's not bad. 0.04. 0.04, eh? Well, maybe it is a 0.04. I don't know. I cannot see. You can see the MFD right there. Yeah, I don't know. Well, it's a strange one because, boy, when I saw that thing sizzling away, and it was sizzling, I just thought, wow, that obviously this cannot possibly be any good, but it tests not any worse than any of the other capacitors. So, am I missing something here? Did something more happen? What more could happen to that capacitor? I don't know. I don't know. Just another mystery. I'll add it to my list. Okay, we're going to plug in the radio now. And we're going to start it up also through the dim bulbs. There they go. Very good. So what we'll do is we'll play the radio, we'll listen to it, kind of become aware of its frequency response, audio frequency response, what it sounds like, and then I will change out this capacitor. See if it sounds any different, which I kind of doubt. And in fact, the one I just changed could have lowered the tone here, but I don't know. Okay, let's tune something in. The voice there. Volume not so great. So I'm listening for the guy's S's. You definitely hear them. Oh, what just happened? What happened? The whole thing got suddenly louder. Come on, radio, don't do these things. What would have caused that? Loose tube. Ooh. Okay, it's gone quiet again. There's a roar. What I did was I just touched the tube shield over here. I want to do it now. Ooh. The tone is going up and down. Is it? Oh baby. Done it now. Now you've really done it. Just when we're talking about the tone. The slow variation, like this, getting better and getting worse very slowly, suggests to me it's internal to a component. The loose connections tend to jump, you know. Wheel some more tubes here. Nothing. Oh boy, what was that? Sound is good. I would think the tone has got to be related to audio circuits. I don't know. Oh boy. Well, it's only running on 97 volts. Something funny going on here. So, with a dim bulb in, I can get this normally with this radio to 117 volts. I've got this turned all the way up now and I'm only getting 106 volts. And this is the wattage based on, I believe, based on feeding into 120 volts. It's not 120. The wattage here, well, you know what? I can read it here much easier. This is easier. Do it this way. 20 watts. That doesn't sound bad. 200 milliamps. 20 watts. Now, they might quote the wattage, but 20 is pretty low. I mean, how much lower can it really be? That's pretty much all the heaters. Watts. What's it say there? 35. So it says 35 watts. The actual draw, it's only 20 watts. Ooh, what was that? Nothing. Okay, let's feed it with the correct voltage here for sure. So what I'm going to do, I'm going to bypass the. I think I'm shaking an antenna wire to make the clicking. So I'm going to crank this down. I'm going to cut out those lights. Put this back on the voltage. 99. Okay, 117 volts supplied to the radio. The wattage is 26 watts. There's 10 watts missing. I don't know how much to rely on this kind of a test. 10 watts missing. How do you have 10 watts missing? There's a light bulb? There's no light for this radio. Is there? No, there's no light for this radio. Well, I don't know. That's my answer to that. I'm going to change out this last capacitor here, the audio capacitor, off the volume control. So power off. Yeah, strange stuff you can't account for. Yeah. Okay, coffee time for a few minutes and then I'll change that last capacitor. Okay, let's take a quick look at the schematic. The capacitor that I just changed, actually I'm holding it in my hand, is this one right here. Now, this guy's probably going to be leaky like the other ones to some degree, which we don't know really, what the degree of leakage is in these capacitors based on the testing I'm doing. It's just a comparative thing. But all these capacitors have shown themselves to be leaky to some degree. Now, so it depends what kind of circuit they're in. This one, if you look this way, you can see this resistor, which is 5 megohms, a great big resistor, and it's going to a grid. This is a very high impedance circuit. Hey, drafts person, where's the dot? Where's the dot? Hey, get him in here. What are you doing? You didn't put a dot there. How come? Okay, enough of that. So I think a little leak here could have a significant bearing on the potential that's developing here. And what potential is developing here? I think this is probably a self-biasing type of grid setup, and that's why the very, very large resistor here. So you could leak that away, I suppose, or leak into it, leak some voltage into it. So, but I've got a brand new 0.01 sitting in here now. So whatever was happening has stopped. It's very hard to check this with a 5 megohm resistor here. Putting a voltmeter on here, you might be able to get an impression of the voltage that's sitting here. Let's let's put in. Let's. Oh, it's already done. Oh, let's test the capacitor. Then we'll run the radio. Okay, come on over here. Yes, I talk to a camera on a tripod like it's a person. Yeah, well, you gotta be a little bit loony to do this kind of stuff, I think. Okay, on the 50 volt test, it opens up on the 150, just like all the rest. Can't do it. And a brand new capacitor, this would pop open all the way up to the top voltage of 450 volts. I checked this many times. This is definitely doing what it's supposed to do. So a little bit of a leak in there. Gone now, because in the radio is this capacitor here. Just checking to make sure it's in solid, and it is. Okay, just using our ears, and yes, you're watching this through a video with your own speakers or whatever you might have there. Oh, this isn't going to work until I plug it in. I've noticed that about all these radios. If you don't plug them in, they don't do much. Here we are. Volume is low. Power on. So there's one great big capacitor left in this radio now. That's this one, which is running between B minus and the chassis. And I've saved that for last. Kind of cleaned everything else out, except it's still got this weird, some kind of weird behavior. 103, because we're going through the dim bulbs again. Voltage is dropping. Let's give it the works here. That's doing pretty good. That's pretty good reception in here. Trying for a French station. Ooh, what is that? The French station is right there. Oh. Oh my gosh, what's happening? Holy smokes. Yikes! Something better. Ooh, that's better. Can't do much with this. So I'm touching a vacuum tube pin. It's coming up through the socket. It's coming up through the socket, and I've got this right on the top of it. Listen to that. It's just going, fading in and out. Whoop. Right on the pin again. I think it's a loose tube. I think it's a loose tube. Or it could be this tube shield is not making good connection. There's just a mechanical sort of just a contact connection here. So I'm gonna unplug it completely just to be sure. Sticking your fingers through spots. Yeah, that tube was not all the way down in the socket. I could see it. I could see it come up. What about these other ones? That's down. They all look good. They look fine. Just this one, I don't think it was all the way in. Okay, it feels very solid. Okay, let's operate again. Let's operate again. Still using the dim bulbs here for safety's sake. I'm guessing that was the problem. Only 96 volts here. Got to give it the full treatment. (1,158 volts). Okay, doing anything funny? Right on the tube pin. Nothing happened. So I think that's what it was. Just tube not quite in there all the way. We have the French station. Okay. That's going to be it for today. Tomorrow we'll go after this big capacitor, or will we? I may not even do this. I may just leave this guy in there. To think about that a little bit. And also I have to review my supply of such big capacitors. Do I really? I have this recently acquired batch of old guys here. Maybe there's a 0.2 in here. That wouldn't work. It's a great big guy. Mallory. 0.15, that's close. 400 volt. But, you know, it's a vintage capacitor, so don't know. Check around, see if I have one. If not, I'll just leave it. Otherwise, what's left here now is alignment to try to pick up the performance a little bit higher yet. Excellent. Excellent, I'd say. Okay, so I'm going outside. The weather today is going to be 30 degrees today. With high humidity, it's going to feel like close to 40. Today and tomorrow will be the hottest feeling days of the summer here in Ontario. That's the prediction. So a couple very hot days, and that's where I'm going. I'm going out to enjoy the heat because I'm pretty sure winter is a-coming. Oh, did I say that? Okay, thanks a lot for watching, and see you on the next video.